So this is Starplat Take 2. Look, I got another Starplat. Bob Lewis was good enough to send me 2 more Starplats after I blew one up, because I didn't really get a lot of initial testing recorded like I wanted to. So today, we'll do some initial testing, and then we'll start ramping it up, and then we'll see if we can kill it with the same conditions as before, because the manufacturer, or the representatives from the manufacturer, said it was probably a faulty board. Now, I personally don't think so. I really just think it lacked the protection that it needed, or my load was set to a way that if it had protection, if the Starplat had protection, the protection couldn't kick in. So I'm willing to take however much responsibility for that. But first, I want to see exactly what's going on with it. So I have my DC load set up a little differently this time. I have it as a constant current, and Mamu told me, based on what she had gotten from one of her associates online, that constant current mode is a little better for testing these boards than constant resistance mode. And it turns out that's the case. If you watch my DNA 40 video that I did recently, it'll show you that I tested the hell out of the DNA 40. It was basically just a limit test. Can I blow up the DNA 40? Turns out I couldn't. So I tried my best. I got it to overtemp several times, and shit, she just wouldn't die. So yeah, I did what I could. So we're not going to do that immediately with the Starplat. I even have, you can see kind of in the edge of the frame here, I'll bring it down just a touch for a second. I have a nickel coil set up here, and I can screw this in and disengage my my load, and we can see how it behaves on an actual coil versus the load. And we'll look at temperature control and all that as well, because I didn't get to do any of that shit last time. So this is just going to be, I don't really have like a sequence of events or an agenda. I'm just gonna roll through stuff as I think about it. So I already have it set up as a 2 amp load. Let me pull this back up just a tad. I do have my scope hooked up, and I'll talk about a few things on the scope. It's not going to be in focus though immediately, so there's no real rush. But you can kind of see what's going on in the background, and we'll talk about that in a bit. So I turn it on, and you can probably hear. Hopefully you can hear that. It makes a little clicky noise. So, and if you can't, I may have to turn the scope off because it's got a loud fan. Let's see. We'll see if that gets picked up. Anyway, it has a clicky noise to it when it runs, and it does that. Let's see. Turn it way down. By the way, this thing will fire at 0.1 volts, which is I don't know if you hear the click, 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 click sound there. And I think I can capture that on the scope. If I grab my trigger just right. Maybe not. No, almost had it. So there's a periodic clicky there, and it does go. And there's some noise in there too, but that's to be had. But it goes up to, it has a fairly flat DC line there, and then it has some clickies in there. So, I mean, it'll technically fire at 0 volts, and then and you still get some plateaus on the. You still get some pulses on the waveform on the scope there. But anyway, so So there's that. I mean, I have to applaud the versatility of it. You can fire at an insanely low voltage for no apparent reason. On the other side, I have to wonder if that was just poor design. Did the manufacturer just not think to put a lower limit on it? You know what I mean? You know what I'm saying? But the specifications stated are 0 to 9 volts, and it will do 0 to 9 volts. So I mean, that's what it is. So I'm just going to dial it up. I have my this right here. All this is doing is charging the batteries, because I'm constantly using them. So there we don't really have much of a click. That's still going, and I want you to notice this as we go down. Let's go all the way down to like 0.1. We fire at 0.1, and the load is pretty constant, 1.993 ohms, and that's not a 1-for-1, by the way. Like 2 amps just happens to be close to 2 ohms. I can change that and show you that it doesn't. It's obviously 5 amps isn't going to look like 5 ohms. With like 0.75. So anyway, back to 2. So we're back there. So let's go way up, and I chose 2 ohms because I can run the gamut of voltages here in variable voltage mode. We'll go to variable wattage. We'll do that. We'll go to temperature control. We'll do a lot of shit. So here we're clicky, but look, we're our resistance is about the same, and that's the beauty of putting this thing in constant current mode, because it ultimately holds a more stable resistance, more stable load than constant resistance mode does. So anyway, so it's firing 9 volts, no big deal. And it's pretty close. It's pretty close to 9 volts there. I can live with it. For whatever reason, it gives it it's reading a constant resistance there, and so it thinks it's running at 42 watts when really we're actually running at 17 watts. So I think that's probably a feature. However it achieves constant current, it probably sets it to a certain resistance and just kind of sits there. And but I don't know. So that's on me. I should probably learn more about how this thing works inside. But fuck it, we're learning about the Starplat today. So so we have a pretty stable signal. When we go into, let's go into some of my annoyances. So 1, 2, 3, 4, 5. Wait. Nope, it didn't do it. 1, 2, 3, 4, 5. So not really what I wanted to do there. 1, 2, 3, 4, 5. There we go. So there's right there one of my annoyances with it is 5-click to get into the menu, but you see I had to do it fucking 3 times for it to act right. And this goes back to something I may have mentioned in the other video, but I'm just going to mention it here again. Starbucks. So this thing has a gravity tilt, but it's a tilt forward and backward and a tilt side to side, which is, I get it, but there's no way to emulate that or place some of the functions of the button, so you have to tilt certain menu features. So let's get back into the menu. 5. God damn it, come on. There we go. Okay, now, so some tilt forward, up and down. Down. I know you can barely see that, but Tilt up. So we go into it. So we're going to go, and these are fairly simple. Like these are actually emulated by the buttons. So I put it in variable. Did I put in variable watt? I did. So variable wattage. Now we're just controlling the wattage, and it is limited by its maximum voltage. So if you get up to 9 volts, it's going to stop. It's not going to go beyond 9 volts to try to reach 50 watts. So if I wanted to get it to 50 watts, I would change the load. So we'll go 3 amps. Enter. So now the setting changed. So now we're firing at there we go. Let me get that triggered so you can see it a little. See that divot a little better there on the scope. If you're one who likes to see what's going on in the background. By the way, speaking of the background, what's up, kitty? He's chilling. Anyway, so we're running at 50 watts, 8 volts. Well, it says, it thinks it's running at 50 watts. Obviously, we're considerably lower than that. But we can get up to that point, and I'll show you. So let me show you what I'm talking about. So we'll go at 1.5 ohms. So 1.5 ohms, and you have to like re-engage it. No, don't remember. So it struggles a bit to maintain, and you can see it struggles to maintain a consistent level, and you can see the resistance is just going nutty. And it's going, so everything's going kind of crazy over here, everything's going kind of crazy over here. So it's not a stable setup that way, and that's why we use in this case. So I'm going to get up to 5 amps, but that's why we use constant current instead of constant resistance, because that's the issue I had before. This constant resistance is basically the regulation mode in here and the regulation mode in here kind of chase each other, and it becomes an issue. So there we are running at quote unquote 5 amps, which is in reality, well, it sees it as a 0.75 ohm load. So and I can kick it up to 10 amps. 10 amps, and then we can see what happens. Oh no, there you go. Fitty. Oh, it didn't do. Hey, come on now. Oh, I must have hit the wrong button. I'm not paying attention. Okay, so now we're not clicky anymore. Now we're working a little harder. So we're putting out 40 watts here now. And I'll I'll refer you back to my DNA 40 video, and you'll see how it behaved versus how this thing behaves on this load. So let's go up to 15 amps. 15, enter. Let's see what she does. So now we're putting out close to the limit, or so it thinks. So I'm gonna do a very short. I'm gonna go up to 20 amps. Bear with me here. Not 29 amps. Let's not do that. All right, let's do 20. Oh, that's what I did. I hit the wrong button. I did hit the wrong button last time. Okay. So now we're maintaining. Now we're maintaining that 50 watt limit. And now I could probably, let me check. I gotta do my heat checks like for real now. Okay, see my MOSFETs, the MOSFETs that blew last time are getting a little toasty. So I'm gonna do. Bear with me here. I can't. My fucking curiosity. I have to sate it. I have to try this. Okay, so it considers that a short circuit. So let's dial it back and find out where our limit is. So it says, the spec sheet says 0.1 ohms is the lowest load that it'll run. Okay, so let's see. So it'll run that, and it's running it at about 50 watts. And I'm gonna check my MOSFETs here. Okay, good. So let's go 6, 7. So we're squarely in the 0.10 range. 8. There we go. There's our short circuit point right there. So we're gonna go to 27 and fucking leave it there. All right. So now we're maxed out. This is as high as this thing will go, and it's it's doing its best to it's adjusting the voltage down, and it's staying within 50 watts, and it's getting periodic short circuit messages there. So I'm gonna take it down to 26. Let's see what we get. See if we can. So there we go. So it does limit itself when it properly reads the resistance. And the problem we had before was the load was telling it had a higher resistance than it actually did, and so it blew up because of that. So it won't run any lower than 0.10, which we've seen here, which is good. So our voltage is very low at that point. So that's good. Let's see. Let's go back to variable voltage mode. 2, 4, 5, maybe. Yes, good. Hey, first try. Look at that. Variable voltage mode. Okay. And so let's do this. So now we're going to see we can't go above. Well, now it's not responding either way. Come on, meow. I got a cat fight going on over there. Cat fight. Meow. They like to fight over the sunshine. So they'll wrestle for a little bit. Getting it in this morning too. Look at that. Anyway, back to business. So let's see, where was I? Okay. So I can't really adjust up or down right now, and I'm guessing it's because of the load that's on it. Question mark? I don't know. Let me turn it off and see if it releases. Okay. So now I can adjust it however I want or whatever. So I'm gonna adjust the voltage way down, and I want to see what happens. Let me turn it back on. Let's see. So now I can adjust the damn voltage again. And I think maybe what it was is, so if I turn it off, let's see. Yeah, so I'm willing to bet I know what just happened. Let's see. So, yeah. I'm going to hold it down. There it goes. So, what it does is it actually retains the setting. So you see I'm hitting the up button a whole bunch and it's not changing, but if I turn this load off, it's going to show the next setting. See, it keeps counting up. It keeps counting up there. So when I go back to my load, and I hit it, it's firing at 2.3 volts, or close to it. And then, but it's not going to show me, and I'm hitting the down button. It's not going to change until it gets below that setting. So that's a little annoying, and that's not very intuitive to the user. But it's a thing, whatever. It's a thing that it's going to do. So so there you go. And it's going to stop right there because that's 50 watts, and that's, yeah, it's right there. It's 50 watts. It's fine. So it really doesn't. I'm like, did I tell me I didn't see smoke coming out of that thing again? Oh, and so these tiny wires are still freaking tiny, but what I did was I put a little dab of hot glue. Let me zoom you in. See that there, hot glue there, to kind of give them some mechanical support when I solder this bitch together. And that's worked so far. At least they haven't come apart yet, so I'm going to call it a win. So anyway, trying to give her a. Ooh. So those MOSFETs are toasty. So about 26 amps. Well, the 26 amp setting, I should say. I should actually get my clamp out. Let me do that. Oh, I told you this was going to be kind of a stream of consciousness sort of thing today. I'm going to have to disconnect some shit to get my clamp around something, aren't I? Okay, so let's do that. I don't need these at all. Not really using my Fluke 87.5 anyway. Oh, I can probably clamp it there. So anyway, Fluke 325. Fantastic little AC and DC clamp meter. If you ever have the opportunity to get a clamp meter, try to get one that reads DC, because it is just well worth it, and it works. It's not bullshit. So let's see how I'm going to do this where I can actually get it in the shot. I'm going to pull it over here. So it's important to zero it, but we pull it here, and we get our 26, pretty much 26 amps right there. And we're starting to go into short circuit shutdown, which is fine. It doesn't really matter. So I put it here, and we're not. Oh wait, what are we doing? There we go. So about reads about 4 amps across the negative there, and put it around the input positive, and it reads about 20 or what? Yeah, about 23 amps, which is not bad. I mean, that's around what it should be. So anyway, so we have our have it around our output, and about 26 amps right there. So good to go. Now let's drop it. Let's since we have our clamp, let's play with it a bit. In case I blow this thing up again. Let's go just drop it to 15 amps. Let's see. So there's your 15 amps right there. Let's push it up as high as we can. So we got our 15 amps. And if we do our math, so we have our 50 watts and 3.2 volts. So we have our 50 watts and 3.2 volts, and we can do the math there. And we have 15.6, which is just about right. So everything's pretty copacetic there. Now, if we look at our resistance, and we look at our resistance and our voltage, so we do Ohm's law, V equals IR, and we take our voltage and we divide it by our resistance, and we should get, let's see what we get. So we have our setting, 3.2, 3.3, whatever. 3.3 now? Sure, 3.3, why not? 3.3, 0.21, 15.7, look at that. So, we're copacetic. Now, let's take it down, 2.5. So now we have 0.5 volts ish at 0.22. So let's see. We get about 2.2 watts, which is somewhere between what it's reading and what it is down there. And if we hit our clamp meter, boop, clamp meter, 3.0. Oops, not what I wanted to do. Let's see. It's trying to hit that that mark, but we're not giving it enough. We're not giving it enough oomph to make it there. Now let's see what we get on our clampy meter. There's our 15 right there. So let's see. 1 volts. So V equals IR. We take our R, divide our V by it, so we have 1.22 divide, and we get 4.5. So my point in doing that is to show you that the resistance reading that it's picking up here, and I'm going to try this, isn't constant. So open circuit, set, no, I didn't want to do that. That's fine. Right there. Turn it back on. Let's see what we get. Nope, still says 0.22. So, and it's firing at 1 volt. So it's not really 0.22, at least not according to, I mean, mathematically it can't be 0.22 because we're firing at 11 volts. So, not 11 volts, 11 watts. So I'm just curious to see no, we can't fool it, at least not with this one. So it's interesting how that works. And that's mainly just however this thing gets a constant current versus how this thing reads it. So anyway, let's go to but anyway, so I guess the big takeaway there is you can't really, at least not in this mode, fool it to driving a higher load than so there you go, 15 amps. It's as high as it'll go. So let's take her down again. I want to see something. Down. Oh, so it says, interesting. Oh, there we go. Okay, so that's what I missed before. So it'll actually go into unreg, and then it'll show you the actual current that it's putting out when it goes below its regulation threshold. So so now we're in there, and we're in. When it regulates, it says CC, and then it shows the actual, which is the current there. So so we go back to, let's see, 26 was our limit there. And we crunk it up, and this is as high as it's going to run with a proper load on it, which is good. So let's go to our coil. Let's play around with temperature control, because the little bit I looked at the temperature control earlier, I was fairly impressed. And I'm going to make sure my so my O-scope is still hooked up. I'm going to disengage this and go into settings. So we're going to go to temp control. This is the one where you have to tilt. Oop, not that way. You have to tilt it to make it work, because you have two different options here. You have right and left and up and down, and you can only control. Okay. And on a mod, it's probably not a pain in the ass, but on a test stand, it is a huge pain in the ass. So the reason it didn't ask me, so usually it asks, like, remember cold resistance, and I say no every time except for this one where I say yes. So I'm assuming it saw that 0.15 cold resistance and said, boom, I remember that's my cold resistance. So we're going to go with that. We're going to assume that's why it's doing that. And if it's not, fuck it. So it gets up to temperature. I'm going to zoom a bit in on the Starplat screen itself, because I want you to really want you to focus on that. So it gets up to a pretty good temperature, and then it allows it to drop, and then it picks it back up, and then it goes back down, and then it picks it back up, and then it goes back down, and it seems to have a fair amount of control over it. Just judging from, like, it's maintaining the resistance within a certain threshold. It's maintaining, which really the temperature is just a function of the resistance. So the temperature reading is just a more refined version of what we see down here. And it drops. The fact that it can drop the voltage that low functionally may actually be the reason that it can legitimately fire at 0 volts, because it may need that functionality to act right. So let's see how far. Let's see. Turn it all the way up, quote unquote, all the way up, and I'm gonna point you guys to the scope now. We're gonna take a look at it, and we're gonna watch the voltage jump up and then down, down, down. And it's going to jump back up, and it's going to jump back down. And I'm going to hey, that was good right there. So I can only assume that's the resistance checking pulse there. So it may pulse a specific voltage and look for a response, and that's how it gets its resistance. So I think that's, and everything else is pretty clear on there. I mean, I have that set to what, 2 volts per division, and if I take it any closer, I'm going to go off the, no, I'm not going to go off the screen. But you have a pretty flat signal. There's a little bit of what looks like rectangular ripple in it, but it's fine. It's a little less clean than the DNA40, but it's much. It's obviously a true flat signal as opposed to the SX350, which is not. In case you didn't know, and you can watch my SX350 versus DNA40 shootout video if you want to see that. But it uses a variable off-time modulation, which is not common. It gets the job done, but it I don't think either of them do quite as well in terms of maintaining a certain temperature, or quote unquote temperature. But we're going to go through. We're going to see. Zoom out here, and we're going to see. I'm going to play around with turning up the temperature limit. I'm going to see if we can get it into runaway, and you're going to know it's in runaway. I don't know how high this thing goes either. We're going to know it's in runaway. Oops. So it drops to 300C is the limit, which is fine. Okay. So we're going to go up to 300C. You know it's going to be in runaway because the coils are going to start getting red hot. It's just going to go way past. It's going to go past its mark, and that's something I noticed with the DNA 40 and the SX350 is, especially with dry coils, it's really easy on those to just run them until they're smoking hot. And it looks like here that's not the case. So this may actually, and this is, I'm not doing temperature measurements on the thing right now. Actually, I couldn't I? Yeah. So I'll do that. We'll see if it's actually going into runaway. By the way, what I'm gonna do here is I have my temperature probe, which I can connect to my Fluke 325 or my 87.5. Just like that, boom, and we get we get our ambient temperature right there. So I can pop this biz into kind of around the coil, and this is basically what I did in my shootout video, except I had it set up to where I didn't have to hold the motherfucker the whole time. So so this should be fun. Let's see. Let's get her right in there without touching the coil. This should be exciting. Oh, I should probably put my fucking Fluke somewhere so where I can see it, and maybe where you can see it. Who knows? Let's go crazy. So you can see that okay a little bit maybe, and let's get the temperature probe out of poking the goddamn coil. Okay. You'd think I'd be used to having something so small and a hole so big, given my history with your mother, but on camera, well, and I should be used to it on camera too, but it's not so easy. Okay, I think, and I'm trying not to touch anything. I'm gonna fucking burn my goddamn nuts off in the process. Alright, so let's just... Yeah, it seems to, and granted, it's not the same temperature. Yeah. I mean, it seems to do an okay job of, like... I think the only issue I see is it has, like, an initial overshoot, and then it has to, like, compensate. But just sitting here fucking going at it over and over again, it's not getting carried away. And it's not even really hitting that limit. So I'd say the temperature control on this thing is fairly excellent. Now I don't have a thermal imager, nor is there one getting purchased on the horizon. So, oh, it looks like she won, by the way. Let's see. It was her turn anyway. So, anyway, the temperature control seems pretty good on this one. Now that we have a way of looking at the resistance without, or rather loading it with a constant resistance without blowing the thing up, now we can play with that a little more. Let me see how hot that is. Okay, it's not so bad. I'm going to back that off. We're going to re-engage. I'm going to play some more. Nope. And you can run it. So see, we're running it in temperature control mode, but like it obviously it's going to show the temperature to be like, I don't know if you guys can see that, but like 21°C, which it obviously isn't. But but it'll run. It'll sit there and run. There we go. You can set it, and it'll drop a bit. So anyway, that's a Starplat. Let me know what questions you have about it, and I'll be happy to do more testing. Let me turn it down a bit. We can play some more with. Let's see if we can get it below its regulation threshold on the thing. There it goes. So we get low, and then we get to this point where it's not really regulated. So there you go. Like I said, let me know if you guys have questions, comments, concerns about all this. I'm going to sit here and max this thing out a few more times. I haven't gotten to I haven't gotten an overheat message yet. I get the short circuit message. I'm going to actually drop it down just a tad lower. I want to see if we can get the short circuit message. Not the short circuit message. I want to see if I can get the oh, that was, I don't know if you saw that. That was smoke coming out of there. Really hope I didn't break it. At least we did a lot more testing this time, but that was definitely smoke coming out of there. And so just so we're clear, this is running at, I think 25 amps is the limit. I asked the guys, like Bob Lewis put me into a group chat with some of the guys with Starplat, and I just said, hey, look, I need every electrical specification characteristic you can fucking provide. And I got nothing. I got nothing from them. So I think, like Mamu said, the limit was 25 amps, and I'm going to generally trust her input without verification, which is good because I can't fucking verify it. So that was definitely some smoke, and I'm trying to like put my fingers back here without like singeing them off. But yeah, shit's getting hot back there for realsies. Let's see if I can. Probably can't. Yeah, kind of can. Oh, yeah, and it's hot enough that the fucking hot glue is melting. So that's an indicator that it's fucking shit hot. So let me see which MOSFETs broke on the last one. Let's see. And yep, it's the same ones where we're getting a little smokiness from. So I'm just gonna. I have another one. Like, so if you guys have questions, by all means ask, and I'll. I didn't put like a Canthal coil in there because I'm like, I don't care. I mean, you can run one on there just fine. I guess I could do that. So before I fuck this thing up any more than I already have, I'm gonna run this out. I can run this without being in temperature mode, just to I guess show you. I don't know. Oh, it really smells like I fucked it up too. Alright, so 1, 2, 3, 4, 5. Pray to God. Just kidding. There's no God. But it worked that time, so maybe there is. Just kidding, there isn't. So we're going to go to temperature control. We're going to hit that. We're going to go down to the nickel, and we're going to tilt it until it goes to nothing. Oh, cool feature, by the way. You can do a custom ratio there, or custom curve setting or whatever for your temperature control, which is nice. Nickel, titanium, custom off. That's good. That you can, instead of, I think it's a good compromise between using external software and only being stuck with one curve. So so I can crank this bitch up. And notice it updates, and this is why I like doing quote unquote temperature control coils with outside of temperature control, because we know the resistance is going to change by a noticeable amount, and this is a good test of any variable wattage system, because even in volt mode, it's going to show the resistance in real time. It's going to adjust the voltage in real time, because like, remember, I'm hitting this button, it's not doing anything, but it is actually changing the highest setting on the voltage. So I can just hit this bitch, and the coil is going to get shit hot. And for any of you who are like, oh my god, you're going to get nickel oxide in those coils, and you're going to vape it, and you're going to die. I'm not going to vape this particular setup. This is no shit, 100%. And if you're worried about, oh my god, you're going to put vapor in there, you're going to kill your cat, like, seriously, you need to stop. But I'm not going to vape this. This is my fucking test setup. I will change it if I fucking vape it, so calm the shit down. So anyway, it's getting shit hot. And then I can cool it off a little bit with some fucking juice. I know there's some juice around here somewhere. Did I not? That's what I get for vaping somewhere else, apparently. Oh, there it is. It was behind my Gorilla Glue. Hey, that would have been a rough mistake to make, huh? Got a little cloudy by nature up in this hizzy. Sup, cloudy by nature. This shit's good. Made by my buddy Nick Crescitelli. So anyway, let's see what we're down to. Okay, so we're back down to like 0.2, and notice the voltage dropped too. So we're gonna do that, and as you see, as it gets hotter, ooh, oh fire, love that. As it gets hotter, the resistance goes up and the voltage goes up because it's chasing that 50 watt mark. I probably am cooking my fucking my ground clip in the process, so we're gonna pull that off before I no, it's not too bad. So I don't want to fucking set my ground clip on fire. So anyway, the whole point of this, besides to heat metal to high temperatures and promote a friend's juice, is to say that this thing updates the resistance in real time, and it does update the maximum voltage in real time. So even though it's in variable voltage mode, it adjusts the voltage up to a maximum point. And let me show you what I mean by that. So we just happen to be at 3.5. I'm going to drop it down. You notice I'm holding the down button for a long time and it isn't moving because I was that high up. So it's going to go up to, so now we're setting, and as we go up, what happens, our wattage goes down. So this thing, if you set your voltage set point higher, that's all cool in the gang. but it's going to change your voltage limit based on the highest wattage, and it's going to monitor that as a function of coil resistance. So, and most of this is like completely transparent to you. If you were to use a Canthal or nichrome coil, you wouldn't really see this because the resistances don't change that much. They're designed. That's the whole point of nickel, or rather nichrome and Canthal, is that they don't change resistance very much at all based on temperature. That's how you can design heating systems around them, is because whatever their cold temperature is going to be pretty damn close to their working temperature. And you can actually look at the temperature coefficient curves of them, and they're more like flat lines than curves. Whereas nickel and titanium have predictable, noticeable curve changes. So I hope I've explained that. I didn't really go into this intending to explain that, so I kind of did it off the cuff. So hopefully you understand kind of what's happening here. If you turn it down, you can almost maintain the level just right. And my coils are uneven too. These coils have been through a bunch of shit, so like they're all fucked up. Which is another reason I'm not gonna fucking vape them. So anyway, Starplat, yeah, that's I'm fucking Starplatting it up today. I don't know, like I could plug in the charger or whatever and test that, but I don't really fucking care to. This is kind of a long video, so I hope that answers all your questions about Starplat. I think I'm gonna, let's see how hot this bitch is. Oh, it's fucking, okay, not too bad. Let's go back to this and see if we can. No. Let's see what we can do. So this is where, okay, I'm just going to go straight into, this is the point where I'm going to try to blow it up. So, so sorry Bob, sorry Starplat, Russian guys, but the whole point of this was to see if using a proper, and notice this is the legal limit. It's running at, I mean it seems to be running at 2.2 volts. I can actually put my 87, my Fluke 87 on it, and oops, that's jarring. Bring it over here. So Fluke 87. Well, I can bring it up a bit. Fluke 87. Let's clip this bitch. I don't really need my scope anymore. Anyway, that goes away. Okay, so I read the output voltage at a much closer point. Oops. You can see my bald. That's the reflection of my bald head right there too. You like that? Get you moist? I know it does. So anyway, so we're running at 2.2 volts, just like it says. Or it's reading 2.3 now, but it's there. It goes 2.2. So it's running right around there, right where it's about where it says it should. Notice I've been pumping 3 amps in these batteries the entire time, and they haven't fucking increased their voltage. So now you see why I have to charge my batteries constantly while I do this. That, and they do get dragged down quite a bit by running it so hard. So I just want you to see that, so you can see that I'm not running it too hard. So we can do 2.2 volts. 0.1 divide, and I want you to understand too that that we're running at within our limits. That's the really big thing I want to convey to you guys. So 2.2 divided by 0.1, that's 22 amps mathematically. we're pulling. So right here it says we have. I'm getting a lot of short circuit messages, which I'm assuming this. So I'm assuming this thing internally is, as it gets hotter, it's going to be affected. It's being affected by the. I'm starting to smell it too. But I still haven't seen an overheat message. And let's see what the actual. Yeah, I mean it's got a little thing for it. Board overheat, needs to cool down. So I mean. It's not making any crazy noises. That's a good thing too. It's not making any crazy fucking noises, as if it were, as if the inductor were about to go crazy. So clearly the hardware can handle it. At least the inductor can. So we're regulating properly. 23. I'm gonna give it a little leeway there. Now we're running below our limit, just so we're clear here. Oops, open circuit. That's not good. Did I pop it? I may have broken it. It may very well have broken this time. No. I don't know why it's saying open circuit. That was a little odd. Oop, there's some fucking. I think that was smoke. Get her in a little closer here. Might have fucking popped it. Not quite as dramatic as the last time. No, it's going. So I'm abusing the shit out of it, and I'm seeing some like. I don't know if I'm seeing wisps of smoke or I'm just seeing the glare off my bald head again, but I feel like I should have gotten a board overheat message like a long time ago. I mean, it's still working, granted, which is good, but but I think it's odd behavior for something that we're trying to push to its limit there. So give me your feedback on that. Any of you guys have tortured tested this thing or run it to its limit over and over again? I'd like to know your point of view on it. But I haven't killed it yet. I mean, I tried a lot harder this time than I did last time, and I haven't killed it yet. So I think that's good news. I'd like to. Oh fuck! Fucking hot glue, man. The shit. Yeah, fucking board's hot. That should be your indication right there. The board's fucking hot. So anyway, love hot glue stringies. So the board's it's getting warm, but there's no overheat message, and it gives other oddball messages. Well, short circuit and open circuit, which to me is not the right answer. And I don't know why it gives a short circuit message at 25 amps and an open circuit message at 23 amps. So you figure that one out. But I kind of feel like it should have given me an overheat message a long time ago. Well, I could do this all day, but I'm going to leave it at that. Box modders, read the fucking pinned post. If you're wondering why you weren't accepted into the group, the answer is you didn't follow the instructions. And all you haters, suck my big sweaty balls, and have a good one. I'm out. Hi, Box Modders. So what's an hour-long video without more shit at the end, right? But I just kind of want to roll up my thoughts about the Starplat. The board itself, in a mod under normal conditions, is a pretty good board. It does its job. I think its fatal flaw is that the resistance reading is a single point of failure. So if the resistance is read higher than it actually is, then you have the potential of damaging or destroying the board. And we saw that in my original Starplat video. I ran it in a situation where it read a higher resistance than was actually on it, and it overloaded the shit out of the board, and it destroyed it. And the representatives from the company said, "Oh, it was defective. We'll send you more." So I got more, and well, the video you just saw, I didn't do the same test. I did a different test to keep it within its limits. But my curiosity got the best of me, and what you're going to see next is the test where I run it the same way I ran it before, at beyond its what was effectively beyond its limits, but the resistance reading was incorrect, so it didn't know that it was doing that, and you'll see what happened. And obviously it failed, otherwise I wouldn't be so confident in saying that it wasn't the first one wasn't a dud. But it's confirmation that this board has a single point of failure in the resistance reading. So if that ohm meter ever reads any higher than the resistance actually is, and you're running a very low, like 0.1 or around there, and it reads 0.15, there's a fair chance that you can destroy the board that way. So is it likely that you'll ever run into that? No, and I don't want you to think that it is. But it is a design flaw, and you need to be aware of that if you're going to spend money on this board, especially if you're going to spend, I think, upwards of $70 on a board that does 50 watts. So be aware of that. I'm not telling you not to buy it. If you have any interest in the form factor and the capabilities of it, and all the benefits of it, like it has very versatile temperature control. It has very versatile voltage range and all this stuff. It has a fairly clean DC signal. There's a lot of good stuff about this board, but don't pretend like it is. Let's not pretend it's perfect. And so going forward, I'm going to show you my my final experiment with it, and you'll see what happens. So I kept thinking about the fact that the Starplat guys said, "Oh, it was probably a defective board, we'll send you another one." So I thought, well, the only way to tell if it's a defective board is to do the same thing to another board and see how it reacts. So I'm going to start out, this is the same board I had before, I'm going to start out with a couple more torture tests like I did before, which is basically running it at its limit, and it runs just fine. No crazy noises, no upsetness. Runs to its limit. That's perfectly fine. I want to run the video on this in case it does pop within its limits, and then I can be like, "Hey, WTF?" So I'm going to turn the I'm going to really crank the fucking current on my on my cells. There we go. Just to give it a little extra something something. So anyway, I'm going to keep running it, keep running it, keep running it. I'm wondering if it didn't give me that short circuit message because of, oh, there's smoke. That's a lot of smoke coming out of that thing, man. Holy shit. I'm just gonna crank this bitch. This beesh. Whew. Yep, that is stinky. That is stinky, stinky. I want to see if I can kill this thing legitimately. And I know, it's not really the right answer. So now we're at a point where, oh, it's angry at me. Oh, it's super angry. Holy shit. There we go. Get some. So I think the camera probably picked up that smoke better than my eyes did. It usually does. It did on the last video, or on the rest of the video I did for this. So I just want to see, because I don't know what that smoke, it is a little bothersome that smoke kind of, like the MOSFETs are cooking the conformal coating off of the package. It just makes me wonder what would happen if you put this in a unit and had it in something other than open air. How rough the situation would be. Still no overtemp. I wanna point that out. Still no fucking overtemp, which I think speaks volumes. Batteries are still decently cool. Okay, so there's like 7 minutes of video in the other video. Going to town on this thing. Come on now. Still no, I get a lot of open circuit messages, and I really don't completely understand why. Unless it opens the circuit as a result of being overloaded, which, that's fair. So anyway, let's go to resistance, and let's put in 0.1. All right. So this is where it failed before. Yep, you can hear it, and it says, you see right there, see right there, I don't have it on a tripod today, so I can zoom right in. Oh, there it goes. It's variable. See, it's varying quite a bit, so it's going to adjust the voltage higher than it should be, and you can see that right on the, see, 72, 60, 60s, 70s. It's going to fucking blow. So, granted, this is a condition. So this is a condition you'll never see on a normal load. You can smell it; it's getting real fucking hot. But oh, hope no one gets upset with me. Actually, I don't really care that much. But I'm gonna go ahead and pop this thing because I really need to show that this is not a condition that you'll have under normal circumstances. But the board has no provisions whatsoever to prevent this from happening. So just understand, I'm doing this for science, guys. I'm doing this for fucking science. There it goes. There they go. Yep, there it is. Oh, that's probably not good. I'm probably gonna have to pull the batteries out of it. Hold on a second. Yep, that's not good at all. Yep, there you go. So that's a lot of smoke. So look, that's the dealio. There is one that was outstanding. Batteries are not hot, so I'm good. So look, that's not a condition that it's going to experience in normal use, but at the same time, let me make no mistakes here. This thing, if the resistance reading reads higher than it should, and you have a very low resistance on it, you will. It has nothing stopping it from blowing up. Nothing whatsoever. So that to me is a potential issue. That tells me, well, one, 100%. The other one wasn't a dud. This is just an unintended weakness in the board. And is it the fault of the manufacturer or the developers or whatever? Not really, because this is not something that any modder should be doing with the board. However, over a long period of time, are we talking about a situation where oh, I could have just turned it off. But hey, whatever. Are we talking about a situation where could the resistance value stop reading correctly? Because that's the only thing stopping this thing from blowing up is the accuracy of that meter. Internal to this guy. And let's go and take a look and see what we got cooking there. Yummy. Look at that. Them's delicious right there. Look at those toasty MOSFETs, bro. So I probably need to get with the manufacturer or the reps or whatever and figure out what MOSFET that is and replace them, because that's I'm pretty sure that's well within my skill set. So anyway, the other one wasn't a dud. This tells me that this is a weakness in the board. It's not a weakness that you should ever experience as a modder, but it's one that, given the right circumstances, is a problem. So call that a caveat to my other video, and we'll go from there. So members of the group, read the pinned post, because it's up there if you're in the group. YouTubers, like, subscribe, share, and haters, suck the penis. I'm out.